I didn't come here to tell you how this is going to end. I came here to tell you how it's going to begin. I'm going to hang up this phone, and then I'm going to show these people what you don't want them to see. I'm going to show them a world without you. A world without rules and controls, without borders or boundaries. A world where anything is possible.
Hey guys, James here from HACK-ATHON, and today we're gonna go ahead and have a look at how the GDB works. I have been getting some requests on making some tutorials on GDB, and I thought of using the Protostar war games exercises, like expert exercises, to go ahead and make this particular tutorial and the later tutorials that would follow. So I have got this particular program here. That's like the first one, the stack one. Ideally, what it does in very brief is like it compares one particular message, looks for a particular message, and if we are able to go ahead and in the input section, if we are able to go ahead and pass that particular message on through a crafted payload, of course, we would be getting this particular message. Else we would be getting a number of zeros. That's it. So having said that, let's go ahead and dig deep into it. So I have compiled that. If I go ahead and type something like this, I'll get this. This program has a glitch because if I go ahead and put a special character, it would go ahead and smash. At times I've gone ahead and seen that smashing. There you go. It went ahead and smashed for some reason. Anyways, uh, to clear GDB -q PS. Now I have gone ahead and compiled this program with -g so that you can go and see the source code, but I would be using disas to go ahead and see where to set the breakpoint. But if you want to go ahead and see how to use the list program, the list command, you can do that, like list one. If you're unsure of how many codes, how many lines that particular code has, you can specify 1 comma and n number of lines, and once the code completes, it will go ahead and give you the source code. Specify, like, only if the -g is specified while compilation of that particular program. So I see that there are 22 lines in this particular code, and I see that in a string copy, which is like the vulnerable function here, is on line number 15, and on line number 17 I've got the modified the comparison, where it will go and compare this. And modify has been specified as volatile int. Volatile is something that would go ahead and change even if stack smashing is disabled, like that's a keyword. So if I go ahead and do a b17 here, I have gone ahead, and it's quite obvious that we go ahead and set the the breakpoint at 17, but I will go ahead and delete this. I delete all the breakpoints, and I'll do a disas main. So here we go. We have to look at a few of the things here. For example, it's going ahead and pushing. First of all, the first instruction is a push to EBP, then ESP, and EBP is on move, and then it's subtracting a certain value from ESP. But what I'm interested in are in the function calls. So here I see that it's calling the ERRX function from this memory address. I suppose I'll have to look up what's the value on this memory address. Well, that should not be that hard actually. X. Well, it can't go ahead and address that particular location for some reason. But if I go ahead and do this, let's say X, Just go ahead and do a simple thing. All right, here, there we go. It has got, like, it's the memory location of ERRX function. Doesn't matter. All right, so it's loading up that particular function there, and here we have got the string function, a string copy, and that's located in this location here. And then what I'm interested in is like the comparison, which would be this. So it's quite obvious, like the modified, like if you see the modified variable that has been set, that was located, that's located in the EAX variable. So it's comparing this value, that's lowercase a b c d, to EAX, and then it's going ahead and loading an effective address, and then it's calling puts, and then it's calling a print function. Well, I guess that's to go ahead and print either the congratulation message or the try again message. That depends on the statement logic, how we go and manipulate this. Right, so I've gone ahead and figured out where I have to set the breakpoint. So to set the breakpoint with addresses, you'll have to use the asterisk like the pointers. So start this, and there you go. I have the breakpoint set on line number 17 here. And if you see, previously I set the breakpoint on line number 17. So my assumption is correct here. This is where I have to go ahead and set the breakpoint. Now let's run something. Run, let's say a, and I'll do an info reg and check the state of the registers. The registers are in this state. Do something here. Minus this. Alright, let me just go ahead and break up Python script, right? So minus, well, EBP should come first, but I have specified ESP first, so a negative value will come up minus 72. So now let me tell you, like, as I'm taking a word here, it will take a four character, or rather four integer delimiter. So I'll have to divide this by 4, right? So 72 by 4, so that's 18. So that's the offset between ESP and EBP. So let's examine the values of the registers starting from ESP to EBP with 18 words, hexadecimal words. So X is like examine 18 hexadecimal words, W is for words, $ESP. So as you can see, I went ahead and fired up a series of A's here. There you go. So that's why I've got A here till here. Now I have to go ahead and understand where the buffer is. So there was like 64, right? So 64 is like 64 by 4, so that's like 16, right? So starting with this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, so I'll have to go ahead and overflow from here to here first, and this would be plus 12. So this is the address. Because as I told you, like the increment in these, when you are working with words, the increment happens as 4. So if I do 8 in this particular scenario, I would be getting this value. I would be getting this particular value. There you go. So that's how you go and calculate the offset. So I'll have to go ahead and either craft my sled in such a way that it will go ahead and create let's say 16 4 byte character 1 byte characters. So what I'll do is like I'll do a run dollar python -c print e into 16 because that's what I figured out, I guess. Yeah, 16. And I'll go ahead and do this. So I'll start debugging again. And I think I overflowed something. E 16 16 4 64. Alright, sorry. My bad. It would be AA. Yeah. This should work. Nope. Yeah, there we go. It was taking that as a string, so you'll have to be careful about those things. But if I do examination of the buffers here, I'll see that I have not overflowed everything. So my initial prognosis was correct. This would be AAAA. And if I go ahead and examine the buffers, there you go. I've gone ahead and overflowed till this, and this is the buffer that I have to go and overflow. So what I have to do is, it's pretty simple in this particular scenario. I'll have to do a little endian bcda, sorry dcba. I get that wrong all the times, I don't know why. Right, yes. And if I go ahead and look at this, yes, I've gone ahead and overwritten this particular memory location, which is responsible for modified, like the modified character, or rather the modified value is stored in this particular location. Let's have a look. It might not go ahead and give me what that is, but then again, let's see. It's not addressing it at this point of time, but once again, like I know for a fact that this is modified. Let's see that. Yeah, all right. So I'll just do a continue, and there you go. I've gone ahead and entered that particular function. So this is my payload. There are other ways to go ahead and execute this. For example, quit, clear what I can do is I can go ahead and pipe this to AAAA, let's say, and if we do an hex edit, I see that this is in the proper little endian order. I can go ahead and do a /PS dollar cat AAA, and that would go ahead and give me the value that I want. So these are the few ways, and the last one that I showed you using hex edit would come in handy in the later exercises, where we would be going ahead and showing you how to exploit buffer overflows to overwrite random memory addresses to execute our own shell codes. I was like experimenting with a few shell codes here, like as you can see here, but those are reserved for later times. But this is pretty much it for this particular tutorial. I hope that this tutorial was helpful. It was a no-brainer, to be very honest. If you understand like assembly language a bit and you know how to use GDB, then these CDF challenges should be a piece of cake for you. No biggie. Once again, like, this was James from HACK-ATHON, and thank you for watching this, and do have a good day, evening, or night wherever you are. God bless you now. Bye bye. Take care.